taking a peek today. We're going to combo some things again. Some stuff from what we learned yesterday, plus some stuff from what we were learning back in our last unit. So, our job here in the example is to find the equation of the line between the points 1, 5, and 3, 9. So we got 2 coordinate points. It doesn't necessarily mean that we've got to graph these to get this done. So here's how we can do it. Step 1. Find the slope using the slope formula. So, as we have mentioned before, it may not be a terrible idea, especially in our notes so we can see them, labeling our x and y values, maybe even in this case in colors to make things jump out a little more. Because now when I jump in and I do step 1, and again, I'm going to try and do all my steps over here. We're going to see how this goes. So step 1, literally just going to plug the values in. So y2 minus is always part of this, y1 over x2 minus x1. And then if I can do that in my head, great. And if not, I can go to my calculator. 9 minus 5 is 4. 3 minus 1 is 2. And 4 minus 2, last I checked, was 2. Okay, and I've got my m value. Okay, that's step 1. That got me a piece of what I need. So, go to the next part. Pick one of the original points. It does not matter which one. Either one is fine. And use your slope from step 1. These are your x1, y1, and m values. Okay? So step 2. Either one of these points will work. I'm going to choose the first one. I don't know why. I just am. So again, there's x1 and y1. And we are given the slope from over here. So you're like, really? I didn't have to calculate anything? It's just write down one of the points. And the answer I got from the first step. Yep. We're going to be a finely tuned machine here. Now we actually get to do the work and get the equation. Plug in x1, y1, and m, just like we did yesterday, into those 3 spots. So I go, okay, let's see. So step 3. Y minus, there is my y1, equals m x minus x1. So I plug those 3 values into those 3 spots. Okay? Step 3 is done. I'm not going to put a line through this time, though, because we want to get to y equals mx plus b form. We want to get to slope-intercept because that's what we're used to being able to have to be able to graph a line. So, just like we did yesterday, and if we needed to flip back to page 1 to see it, we could. We're going to do a little distributing. So we're going to multiply the 2 times the x, the 2 times the negative 1. And it looks to me, at least, like the only thing left to do now before we're done is I notice the y is by itself here. So I want to get the y by itself. How do I undo the minus 5? Plus 5. And again, we're going to do that to the number term on the other side, not to the x term. So I get that out of the way. Negative 2 plus 5 is 3. And I've got my equation. So now you might be like, okay, that still seems like a lot of stuff we're doing for one question. But let's think about it for a minute. Really all I'm having to do is I find the slope. I don't really have to write this step down. We just do it because in our example we want to see. You're like, wait, would I have gotten the exact same answer if I would have used the 0.39 instead of 1.5? The answer is yes. At the end, you would end up with the exact same answer. So sometime we have to test that out. So when we're doing these, typically almost every problem you do will end up looking like this. But of course, there occasionally is going to be an exception. So let's chat the exception for a minute, even though we'll see some more normal ones. Example 2, you're like, okay, looks kind of like what we did there, so let's do the same thing. So there's x1 and x2, and y1 and y2. And we're just going to follow, let me move this back down a little so we can see, what we did up here. So step 1, we're going to do slope. So we got y2 minus y1 over x2 minus x1. Just following it along. So 2 and, problem. Like, what's the problem, Hardy? 2 divided by 0 is undefined. How the heck am I going to stick undefined into an equation? I'm not. What the heck are you going to do then? Undefined, if we remember back, means if I had a picture of my line would go like this. It's vertical. You're like, okay, so how does that help me in figuring out what my equation's going to be? Here's the trick. When you get undefined, there's something special that's going on that we got to take note of. The x values are the same. So here's what I would say to write for a note here. What's up with the x values? They're the same. Okay, so you're like, so what does that mean? That's the x value, right? Your equation then is x equals 4, because x equals is the equation of a vertical line. So anytime you see this happen with x, it's also true for y. So here's what I mean. If, for example, we'll put another example in here. So let's say I had 2 points, 1, 7, and 9, 7. Now, I could go through, do all my other stuff, and see that, but if the y values are the same, I can just put y equals and that number, and I'm done. If they're different, then we just do the normal thing. But I'd always check the beginning to see if my x's are the same or my y's are the same. I just write that and I'm done. That saves a heck of a lot of work. So that's something worth jotting down and noting when you're doing these. But those are the only 3 options. Like I said, we'll see some more normal ones here in a minute when we do a couple of the practice ones. Oh my gosh, Artie. Not more applications. Yeah, more applications. It's all right though. So okay, the cost for 7 dance lessons is $82. All right, 7 dance lessons, $82. The cost for 11 lessons is $122. In general, I mean, not everything will be dance lessons and money, but the amount of whatever it is you have will be X. The money-like amount would be Y in general. So write a linear equation to find the total cost for L lessons. Well, we're not going to worry about L and C. We're just going to use M and X and our normal stuff here. So job 1, find your slope. Like, we got this. Table our X's and Y's here. Following exactly what we've seen at the top. So y2 minus y1, x2 minus x1. Again, we got to keep them in order though. Y's on top, x is on the bottom. Reduce it as much as we can. Might you get a fraction sometime here? You might. You might, but if it cleans up, we need to clean it up. Get that set. So my m is going to be 10. Again, you can pick either point. It doesn't matter. Oh, let's mix it up. Let's do the bigger one this time. So we're going to do 11 and 122. Reminding ourselves that I've got all the info I need. Y minus my Y value, 122, equals my M, my 10, X minus my X value. And again, if you use 7 and 82 instead, 82 here and 7 here, you're going to end up with the same answer. Now my last job's to get my distributing done, my multiplying done on the right. And to finish it off, my job is to get y alone. So I'm going to do the opposite of a minus 122. Just hang on a minute there. And that's going to be 12. And I've got my equation. Steps are always going to be the same. So if you've got everything written in here and you've actually heard the things, instead of writing and not focusing, it's going to click. And if you're doing other things, it's probably not going to click. And that's okay, because life is full of choices. But keep this handy, because when we pull out the practice, and that is a 3 that got kind of cut off there. As soon as I get through here, yeah, actually, I was going to say, I got it right there. So again, I'll run through a normal one with you, but then I'm going to kind of get you to look around and see, okay, let's see if we can find something that's a little bit different maybe out there that we can find. So let's see here. If we start with the first one, good place as any to start. So I got my X's. I got my Y's. Grab one thing. out of here quick while we're getting that jotted down and labeled. Okay. So I start working on my slope. So again, we're going to have our y2 minus our y1 and our x2 minus our x1. All right, let's see what we get. 7 minus 1 is 6. Negative 2 minus 1 is negative 3. And that's going to reduce down. That, again, is our m, our slope. So we got that part. If I'm kind of trying to look for some guidance, too, I can kind of be like, okay, so I got that. Pick one of the original points. Again, it doesn't matter. We want to do the first one we can. So let's say we do 1, 1. I'm going to keep labeling as I go till I'm feeling comfortable. And then I just look at this and tell me where to put it. Okay, that blank is y1. So I put the 1 there. That blank is my m. I just got that here. That's negative 2. My x1 is right there. It's 1. And my only job left is going to be 2 steps. And it's going to be the same 2 steps that we did over in our examples. First step is to distribute, to multiply. Again, be careful for little things like negative times negative is positive. And then you got 1 step left to get y alone. The number in front of x didn't change, so we just leave it. And 2 plus 1 is 3. Dang, that was almost like the same. That's kind of weird. Kind of weird. So I can work through some of those. But be careful. This is all I'll say. Be careful, because sometimes you're going to see the same number repeat for your x's or the same repeat for your y's. And that's going to make your life very, very easy. Especially if you were jotting down the examples that we did earlier. You'll have something exact to copy, and then you don't have to do all the work because you were kind of a detective and snipped that right out. So that's not a bad thing either. Now, I do want to do this application problem because these are the biggest numbers I think we've had to deal with in all of this. And I think that can freak some people out because it's going to get a little strange number-wise. So, whoops. It would help if I actually moved up to where we could see the story problem. Okay, let's try this again. The population of Laredo, Texas was about 215,500 in 2006. It was about 123,000 in 1990. If we assume the population growth is constant, and we need to change one thing, X, not Y, represents the number of years after 1990. We'll explain what that means in a minute. Write a linear equation to find P, Laredo's population for any year after 1990. Okay, let's chat about this. This means that in 1990, x equals 0. Okay? They're saying like the world began in 1990, according to this problem. So, when I'm looking at these dates, I'm trying to figure out how many years after 1990 they were. So you're like, well, 1990 is the date. Okay. So for that one, we're going to use x equals 0. So for this first point, my x is 0. And the y is the population that goes with it. 123,000. When I do this one, the population, again, will be my y value. Oh, my pen's going dead. Let's try this one. But here, I'm not going to use 2006. If 1990 is 0, I need to know how many years after 1990 2006 is. And that will end up being my x value. That's the one twist that can come with these problems if there's dates involved, because they normally don't want you to use the date itself. So if I survive that part, now it should be normal. Now let's see what normal looks like with these big old numbers. So let's see. x1, x2, y1, y2. All right, let's do this. So big old 215,500 minus 123,000. Just subtract my y's. And then on the bottom, we got 16 minus 0. I cannot do that in my head. I'll admit it. So 92,500 divided by 16. Okay, this ought to be interesting. Ooh, decimals. You're like, okay, Hardy, so what do we do when it's a decimal? In an application problem, we can get away with it. That's not our best case scenario, but we can do this. So, okay. Normally, we would just leave fractions, but applications can be a little weird. So we'll roll with it. I can use either point I want. So, hey, I see 0 as one of the numbers. I like that idea. So, whoops, I lost a 0. Hang on, there we go. And here I go plugging my numbers in again. And if I need assistance, guess what? I have it. So, y minus y1 equals m, so that decimally number I got here, x minus x1, which is 0. We'll just make an adjustment tomorrow. We'll make it work. So here's my cool thing. If you distribute that decimal, it's going to be the easiest distributing job ever, because this big old decimal times x is just the decimal times x. And anything times 0 is just 0. Okay, I'm down with that. And my last step is to get y alone. But remember, this is just a number. It doesn't have x. So when I'm adding the 123,000, I'm not doing it to the decimally stuff. That's got x. Don't do it. The decimally x number gets to stay that way. And this is more real life. Like, not every problem you're ever going to deal with is going to come out a nice whole number, and they're little. This is bigger stuff. Towns have to do stuff like this to know what they're going to need for supplies and services and things like that. So people do stuff like this to give them an idea of how big their population's going to be. So it can get a little screwy. Don't get me wrong. But, you know, if we follow the same process, we're going to be good. Oh, let's do this. All right. It's student selection time. We have 5 problems here on the back. We got a couple with angles and 3 with equations. Which one am I doing? I'm only doing 1, though. Which one am I doing? That's where I wish I had a random randomizer up. Oh dear. Let's see. I'm trying to come up with a good way of picking this number myself. All right, I'll do it myself. I'm going with 11 because I like the double number. Two things to make mention. I will help on one other thing. Give a little help with the setup of the equation on number 12. But number 11, I do have one question that I need assistance with. So I got these two angles. The angles aren't the same, but they do together make this straight line. How many degrees is a straight line? 180. So 3x minus 3 plus x plus 7 is 180. So before I go to try and solve this, I notice on the left side, there's a bunch of stuff with like terms that I can put together. So I can take the 3x and the 1x and put them together. Not opposites, because they're on the same side. Negative 3 plus 7 is 4. Now it's a regular old two-step equation that we've been doing since the first week of school. My job is to get the x part by itself. Let's see here. Now, here's the thing, though. I mean, good job. We got x. That's any good mathematician in an algebra class. You get to x. That's a good thing. But that's not what the blanks are for. The blanks are asking me, okay, angle ABC, we're plugging the 44 back in here. So we've got 3 times 44 minus 3, because I'm substituting my x value back in. 3 times 44 minus 3. 129. And then for CBD, I'm plugging it back into this x plus 7. So 44 plus 7. And I get my two angle measures. So your job again is to knock the rest of these out. And again, the more practice you get, the easier it's going to be when we do see our next quiz. So just be aware, okay, think it through, and get those practices done, and we can start getting you some really nice grades heading into break.